Welcome to Grade 10 Chemistry, Universal Indicators and pH Scale. We have learned about natural indicators, synthetic indicators and olfactory indicators to identify acids and bases. But indicators do not tell us how strong is the acid or base. If two acids are given to you, how can we say which one is stronger and which one is weaker? To solve these issues, universal indicators and pH scale are introduced. The pH scale is first introduced by the Danish scientist Søren Sørensen, and pH is taken from two terms P and H. P, potence, it's a German word, it means power, and H stands for hydrogen ion. So we can say pH is the power of hydrogen ion, or pH is the measure of concentration of hydrogen ion in a solution. Acids, hydrochloric acids, acetic acids, sulfuric acids, nitric acids, they have higher hydrogen ion concentration. That's why we call it as acids. Whereas bases, sodium hydroxide, potassium hydroxide, they have lower concentration of hydrogen ion than water. That's why they are called bases. Then pH is minus log hydrogen ion concentration. So hydrogen ion concentration, the negative logarithm of hydrogen ion concentration is pH. So this means that the higher the concentration of hydrogen ion, lower will be pH. Lower the concentration of hydrogen ion, higher will be pH. So acids, they have higher hydrogen ion concentration, but they have lower pH. And bases, they have lower hydrogen ion concentration, they have higher pH. And once again, pH is minus log hydrogen ion concentration. On pH scale,
we measure pH from 0 to 14 and the midpoint 7 shows the solution is neutral. Neutral means neither acidic nor basic. As pH decreases from 7 to 0, the acidity increases. That means the acid with a pH of 2 will be a stronger acid than an acid of pH 4. So as pH decreases from 7 to 0, acidity increases. As pH increases from 7 to 14, basicity increases. For example, a base of pH 10 will be more basic than a base of pH 8. So the stronger the base, higher will be pH, and weaker the base, lower will be pH. Acids such as hydrochloric acid, sulfuric acid and nitric acid, these H plus ion make it acidic and they have low pH like pH of 1, 1.2 like that. And bases such as sodium hydroxide, potassium hydroxide and lithium hydroxide, then this OH minus ion make it basic and these bases will have higher pH of 13 to 14.
now let us discuss some of the strong acids and weak acids. Strong acids such as hydrochloric acid, sulfuric acid and nitric acid, They have higher concentration of hydrogen ions and lower pH. The pH will be very low, between 0 to 1. Whereas weak acids such as acetic acid, citric acid, formic acid or methanoic acid, their pH value will be between 2 to 3. They have higher pH compared to strong acids pH. Comparing strong base and weak base, strong bases such as sodium hydroxide, potassium hydroxide and lithium hydroxide, their pH value is between 13 to 14. They have high pH value, whereas weak bases such as ammonium hydroxide, sodium carbonate, their pH value is less than pH value of strong base. Here is the list of pH of some common solutions in our everyday life. Saliva, the pH is between 6 and 7. Lemon juice, pH between 2 to 3. And coffee, 5. And milk and urine, 6 to 3, 6.3 to 6.6. And tomato juice, 2.5 to 3.5. Egg white, 7.8. Human blood, 7.35 to 7.45. Pure water, 7. And tap water, 7 to 8. Synthetic indicators are used to test whether the solution is acidic or basic. But synthetic indicators do not tell us how strong is the acid or base. In this case, universal indicators are used. Universal indicator is a mixture of 4 synthetic indicators. They are thymol blue, bromothymol blue, methyl red and phenolphthalein. Universal indicators can be used over a complete range of pH from 0 to 14. It is prepared in the form of a solution or a strip of paper. The strip of pH paper is very convenient and handy to use. To find the pH scale chart is used. Let us discuss how to find the pH of a solution using pH strips. Dip the pH strip in the solution to be tested. Match the color of the pH strip with the pH scale chart. If the color of the pH strip matches with the particular color of the pH scale chart, the number corresponding to that color is taken as the pH. Now let us discuss some questions based on pH value. Arrange the following acids A, B, C, D of pH 3.5, 1, 2.5 and 4 in the order of increasing acid strength. We know that in the case of acids, higher the pH, lower the acidic strength. So in this case, the acid D will have higher pH, that's 4, and D has lower acidic strength. Then comes the acid A of pH 3.5 and then acid C of pH 2.5 and then the last one, the pH of 1. The acid B has the highest acidic strength. So this is the order D, A, C, B. Question number 2. Arrange the following bases L, M, N, O of pH 13, 7.5, 11 and 9 in the order of increasing basic strength. In the case of bases, higher the pH, higher the basic strength. So the base of pH 7.5 will have lower basic strength and the base of pH 13 will have higher basic strength. So this is the order M, O, N, L.